Life had begun. Not loudly, not dramatically, not in a way anyone could notice. But once it existed, it stayed. For an almost unimaginable stretch of time, the Earth belonged to single cells. No forests covered the land. No creatures moved across the surface. No eyes ever opened. The planet was still mostly ocean, and the oceans were alive in a way that could not be seen from above. Every drop of water held life. Cells drifted endlessly, carried by currents, rising and sinking, spreading into every corner where chemistry allowed them to survive. Some lived near the surface. Others thrived in darkness, deep below, close to heat and minerals rising from the seafloor. There were no bodies, no shapes to recognize, no behavior to observe. And yet, this was the longest, most stable era of life Earth would ever know. Each cell was complete in itself. Inside its fragile boundary, chemistry ran like a quiet engine. Energy entered. Reactions continued. Molecules were built, broken, reused. When the internal balance held, the cell endured. When it failed, the cell disappeared. No cell knew it was alive. There was no awareness of success, no experience of failure, only persistence. Division was the closest thing to reproduction. When conditions allowed, a cell copied its contents and split. 2 became 4. 4 became 8. Not as a goal, but as a consequence of chemistry continuing long enough. Over time, variation appeared. Not because life was experimenting, but because copying was never perfect. Some cells were better suited to heat. Some tolerated salt. Some survived acidity. Others thrived where energy was scarce. Every environment became its own quiet filter. Cells that fit remained. Cells that didn't vanished. This process unfolded slowly, so slowly that from within it, nothing would feel like change at all. Millions of years passed. Entire oceans cycled through warmth and cold. Continents shifted. Sea levels rose and fell. Ice sometimes reached toward the equator, then retreated again. The cells endured. Single-celled life adapted not by becoming more complex, but by becoming more specialized. Some relied on chemical energy rising from the Earth itself. Others interacted with sunlight near the surface. Some fed on the byproducts of others. Invisible ecosystems formed. Not food chains as we know them, but networks of chemistry. One cell's waste becoming another cell's survival. Life recycled itself endlessly, reshaping the oceans molecule by molecule. For most of Earth's history, this was enough. There was no pressure to become larger. No advantage in developing bodies. No reason to sense the world beyond chemistry. Complexity is expensive. It requires energy. It requires coordination. It requires stability. And the early Earth was not stable. Asteroid impacts still occurred. Volcanic eruptions reshaped coastlines. The atmosphere fluctuated. Oceans changed chemistry. Entire regions became hostile, then hospitable again. Single cells handled this chaos better than anything else could have. They reproduced quickly. They adapted chemically. They survived catastrophe by sheer numbers. When disaster struck, most died. But some always remained. Extinction at this scale was never total. Life did not cling to individual survival. It spread risk across billions of tiny existences. Loss was constant, but irrelevant. The planet itself became a living system, cycling matter through countless invisible lives. For billions of years, nothing like intelligence was even possible. There were no nervous systems, no signals traveling through bodies, no memory beyond chemistry. And yet, something subtle was changing. Cells interacted more often. They bumped into each other. They competed for space. They altered their surroundings. In crowded environments, efficiency mattered. Cells that used energy more effectively persisted longer. Cells that reacted faster to environmental change survived more often. Still no thought, but responsiveness improved. Chemical sensors became more refined. Internal reactions became better regulated. Timing mattered. Balance mattered. The difference between survival and failure grew thinner. Cells began responding not just to immediate conditions, but to gradients. Light, temperature, chemistry shifting slowly over time. Reaction pathways became more complex. Not intelligent, not aware, but increasingly dynamic. For most of this era, the surface of the land remained barren. No soil existed. No roots broke rock. No life crawled or walked. Only wind, water, stone, and time. If you could stand on a shoreline during this age, the sea would look empty. No fish, no waves disturbed by movement. Just water. And yet beneath that surface, the ocean would be alive beyond measure. Trillions upon trillions of cells, living entire lifetimes unseen. This was Earth's longest equilibrium. A world where life dominated the planet without ever becoming visible. Without drama. Without awareness. Without direction. Single-celled life ruled not because it was primitive, but because it was resilient. Complexity would come later. Much later. And when it did, it would only be possible because of this era. Because life had already learned how to persist, adapt, and survive catastrophe without minds or bodies to guide it. The Earth was alive, but it did not yet know how to feel that life. This was the long age of single-celled Earth, a chapter so vast it makes everything that follows feel brief. And still, the conditions were slowly changing. Not suddenly, not intentionally, but inevitably. Because even in a world of simplicity, change never stops. And in the quiet chemistry of these countless cells, the groundwork was being laid for something the planet had never seen before. Not yet, but soon.